Oh, hello. We're going to do a simple introduction to test-driven development by giving a real code example or to show that TDD is more than a test-first approach of writing a failing test and making it pass. It's a test-driven approach, so we use a test approach, but we use baby steps as well. It's mostly about design and letting the test drive the creation of production code. As the test gets more specific, the code gets more generic. So we're going to do a prime factors kata, and the kata states that we need to write a static method generate that, given an integer n, will return a list of integers containing the prime factors of n and arranged in increasing numerical order. So the first example we have is generate 1 should return an empty list, and generate 30 should return the numbers 2, 3 and 5. So let's get started. Let's just run this to make sure that I've got a test framework up and running. Great. Let's delete that and let's write our first test. So generate a scenario with number 1, return empty list. We want to have a list of int, which is the result of a prime factor generator that generates 1, we should then return a result which is equal to empty. Great. Just run that. Okay, let's make that compile. I need to put those up there. Okay, let's create a static class. Yes. Generate. Yes. Okay, let's run a test. Okay, so now we've got a failing test and we need to make it compile. I do prefer sometimes to make it explicitly fail than just having that, so let's just do this. Great. Right. So let's write some production code to make that pass, and we need to do the most simplest thing to make it pass, and the most simplest thing is we create an empty list. Fantastic. So we have now got our first passing test, and once we have a passing test we can refactor. So let's take some of the stuff we don't need, which is that. We can get rid of this dead code. We also would like to put that in its own file, and we'll bring it over to the right here so that we can see both at the same time. I've done changes so I can refactor. That's great. Right, so let's write our second test. So that will be generate with number 2 and with return a list containing 2. Okay, so now we've got result equals prime factor generator, and we're going to generate 2, which this time is going to assert that the result is equivalent to Fantastic. So I've got my next failing test, and which is saying that it's expecting a list containing 2 but was empty. So let's make that passed. So in here we've had a constant, we had null, we've gone to a constant, and now we need to look at maybe the next step, which is a variable. So let's first of all change this into a variable which returns primes. Now we've added nothing new, should be the same. Fantastic. Right, so let's write some new code. So here and here we are going to, I've seen some refactoring I need to do. Got an I in there, not very descriptive. So if I equals 2, then we want to primes dot test, got green state. Okay, so let's change that to be number, so explicit. Again, refactored some code. Right, so we've fixed up the production code. We've got some duplication here, and I know that I'm going to need to keep doing this. So let's see if we can write this in a parameterized way to make it easier for going forward, as well as remove the dry validation that we have now. So let's make it a parameterized test case. I can do this. Just make it a bit quicker for me. What I should do. Right, I will then take that and put it as a parameter. Yes, yes, and I will parameterize that as a expected list. Right, I will change this to return expected list and with number 2. Right, so let's run the test to make sure that we're in the same state. Great, we're in the same state. This time now I can replace this with something similar. So this time I've got 1 and I want it to be an empty list. Great, so I can move that duplication there. And I can now easily write my next test, which is 3. Okay, so we've got a more generalized test, so we need to generalize the code. So in here we've got a constant of 2, and we need to make it more generalized. So we put number is greater than 1 this time, and I want to use the Scala, i.e. the parameter, instead of constant. Fantastic. Right, no refactoring to do, it looks all clean for me. Let's go straight into 4. So 4 is 2 and 2. Let's run the test. Great, I've got another failing test, so now I can write some production code. So in here it's saying, right, I expected 2 and 2 when I passed in 4, but I got 4. So what I need to do in here is add some more functionality. So with when we pass in something that's a 4, and I only want to add 2. So if I do number is mod 2 equals 0, that will let me handle the 4, and I do primes dot add it 2, and I want to add the second 2, so I've got here, so I can do number divided by 2. What way? Run the tests. I've got that to pass, fantastic. But on passing that test, I've actually failed another test, the one previously, which is 2. And the reason why it's doing that is because it's adding 1, and we don't want to note 1 to the list, so we want to do primes, sorry not primes, number is greater than 1. So it's only allowed to add it if it's greater than 1. Fantastic. Passing test. Right, so I can refactor. Some duplication here, but I had to put that line in. Let's just take this out for now and just put it here to kind of highlight that for some reason I've got some dry variation there, but I need it because the tests are telling me I need it. Right, so there is some refactoring I can do here because I don't need to be explicit because I put that already in. I can now write my 5, which I don't need because it's a passing test. And let's just prove it out quickly. Okay, 6, same as, should be 2 and 3. Oh, so but it already passes, so I've already got a logic for 6. That's interesting. It's not a passing, it's not a failing test, so I can delete it. I could keep it if I thought there was additional complexity that is valid for that reason there, but there's extra maintenance that's needed for that test, which is not required. So let's do 8 is the next one, which is 2, 2 and 2. Let's run the test. Now I need to look at the code and see, right, okay, how can I generalize this to make this pass? Is there anything I can do to generalize this? And this is because I want to do basically repeat this. Before it was just 2 and 2 for 4, but what I want to do is basically change this if, whoops, into a while. Fantastic. So I've got this passing test. So I've just literally changed an if to a while. So this is saying, right, we are now, the tests are getting more specific, the code is getting more generalized. Right, let's write the next test. So 9 is 3 and 3. Failing test, great. So same as before, I want to kind of generalize it. And I've got this 2, but now I want to be able to deal with it when it's got 3. So when 9 comes in, I have 2 goes straight over there and goes into 9. So I need to generalize it. So I'm going to literally take this out and put it into a variable first. So let's do that. Replace, and I'm called divisor. Great. I'm going to put it out of the section. And that's because I've done changes. I'm running. Okay, in the same state as before. With that, I can probably change this now if statement to be more generalized to a while loop. And what I want to do is I want to test 2 and then I want to go around and try 3. So if I do divisor plus plus, that should be good. Yes, it is. So it's all green, and I can now refactor. So I can see that this condition now is never met, because if it comes out of this, then that's always going to be true. So I can delete that, and the beauty about my test is now I can just verify that quite quickly. Great. I can remove that, don't need that. That's it. Oh, and I can remove this dead code as well. Right, I think we're probably there, but let's go on to the next test. 10 is 2 and 5. Great, it looks like we've probably got the formula, but let's try one more then, just to verify that. So if we did 30 in the actual example, it was given, it was 2, 3 and 5. Great. So can we refactor this even further so it's even less code? Yes, we can. So if we look at the while, we can change this into a for loop. And we can do that by doing this. Great. And same for this one, we can change this while into a for. We can take this into here, and we can take this into here. Right. On the test, great. So we're saying the for, and we can remove the embraces because we don't need them as they're all one line. So as you can see, we have basically 5 lines of code for this kind of kata. I hope you enjoyed it. If you'd like to see more of this content, then please like and share. Hope to see you next time.